Okay, Assalamualaikum and good day everyone. Okay, now we are still in the same topics, or previously we have generalization of elementary real problem. Right? Okay, now our next topic here today is invariance of Euler equation. There is nothing different as the previous one that we have discussed in parametric functional. Okay. Now, for invariance of Euler's equation, we just replace our x and y with another independent variable. Okay, so there are instances where we have to transform a functional in order to easily solve this. Okay, this transformation involves either the replacement of the independent variable or replacement of both independent variable and the function. So to find the solution of the new functional after we replace, we have to set up an Euler's equation based on our new functional, which consists new variable. So the question is the extremal of the new functional also the extremal of the original functional? Right, so let's take a look. Now, all right, previously, what we have been doing is having this functional, right? We have a functional, but the functional consists of x, y, and y prime. Now, if this x is in terms of u and v, and y is in terms of u and v, then the functional of x, y, and y prime now, x can be in terms of u and v, y can be in terms of u and v, and y prime here is given by this, where this is the process of differentiation between between x and y here. Okay, then this is another product rule of the process of differentiation. So this is a general form, don't worry. After this, we're going to take a look at the example. So having this now, simplify this functional of f. Now we have phi of u v prime u du. And instead of having the Euler from fy minus derivative with respect to x of fy prime equals to 0, 9, now becomes phi v minus derivative with respect to u of phi v prime equals to 0. Same Euler equation, but with the changing of variable. So if the solution given by this Euler's equation, the extremal of the original functional, we don't know. Let's take a look. Okay, now let's take a look at this example. We have a functional, say, given a functional here consists of x, y, and y prime, right? Now, how can we change this? Okay, by I equals to v, show that its extremal is yx equals to ae to the power of e to the power of x plus be to the power of minus e to the power of x. Okay, so now let's take a look. Given x equals to ln u, right? Then dx du equals to 1 over u, okay? And y equals to v. dy dv equals to 1, right? Why we have to differentiate? Because we want to map with the original functional where it involved with y prime. And in order to get y prime here, we have to find our dy dx, where dy dx by chain rule here equals to dy dv times with dv du times with du x. All right? So from here, what is our dy dv? Dy dv equals to 1. Okay, and dv du is given by v prime. Okay, we have no dv du function. Okay, the involvement of v and u there, then we just put v prime there. So du dx equals to u. So we have y prime equals to v prime u, right? Okay, so now given our functional is given by jyx equals to integrate from a to b of exponent minus xy prime squared plus exponent xy squared x, right? Now we substitute. Instead of having a functional in terms of x and y, we want to change this functional j, y equals to v now, and v is now in terms of u, because y in terms of v, x is in terms of u. So we have here integrate negative ln u. Y prime squared. Y prime is given by v prime u squared. Okay, and plus exponent ln u times with y squared. Y is v squared. Okay, now what is our dx? Right, so dx is 1 over u. Okay, so change everything with the variable given, right? So now from here, what we can have, simplify the function. So from here we have what? We is silap sikit. Okay. Here should be 1 over u, v prime squared, u squared plus u v squared. Okay, 1 over u. So we just eliminate this u here. This one also can be eliminated. Then we have v prime squared plus v squared. Okay, so as you can see, if jyx have f in Euler, right? So now we just change to phi, because Euler equation given by phi v minus d du over phi v prime equals to 0. So our phi now is equals to v prime squared plus v squared, right? So phi v is equals to v, okay, minus differentiate phi v prime to v prime with respect to u equals to 0, right? So here we have 2v differentiating again, 2v prime again differentiate with respect to u, we have 2v double prime equals to 0. All right, so now we have here negative here. We put the negative, so then we can have 2v double prime equals to 2v there, right? Rearrange, simplify, we have v double prime minus v equals to 0, right? So from here, solving this, second order differential equation, we have the solution of v here equals to AEU plus BE to the power of minus U. This one is m squared minus 1 equals to 0, m equals to plus minus 1. Okay, now from here, this is the extremal that we obtain after we change the variable x with u in terms of u and y in terms of v. Now from here we have our vu equals to ae to the power of u plus be to the power of minus u. So again, refer to the given function, right? Since u equals to ex and v equals to y, where does this come from? The original problem. When x equals to ln u, then u equals to e to the power of x. When y equals to v, also v equals to y. So we use this. Now we use this and substitute again. What is your v? Yx now becomes ae to the power of ex plus be to the power of minus e to the power of x. Same, right? So by changing this, we can find the function, the extremal in terms of u and v, and also the extremal in terms of x and y, right? Same process, but with some changes of variable, right? Okay, so by using the same approach, I want you to try the second example, and if you have problem, can discuss tomorrow, right? Okay, so I think that's it for the okay, this is the another example given in your notes, right? Okay, so that's all. Please try it first, okay, and then we can discuss. All right, thank you. Assalamualaikum.